I'm Anil Kumar, and in this series, I've taken up few videos to practice factoring polynomials. So we'll begin with simple examples. This one is based on grouping. So we have 6 examples here. You can always pause the video, copy the questions, factor, and then look into my suggestions. The first one here is x times b minus a minus 2 times a minus b. Right? This is kind of tricky. Since you cannot really see the common factors initially, what we can do here is we can slightly change the question. So if I write this as x times, let me keep this as b minus a. Now if I make the sign positive, right? If it is negative, it is negative a plus b. If I write this as positive 2 times, it becomes b minus a. Do you see that? So that's the kind of trick here. Now b minus a and b minus a will be common factors. So we could factor as b minus a times x plus 2. So when we get product of two factors, we call it factored form, correct? So this one is a tricky step. Let's look into the next example. Y p plus q whole square minus 3x times p plus q. You could straight away see p plus q is a common factor. So we can write p plus q as a common factor. And we are left with y times p plus q here, right? So let me use square brackets since we have another bracket like that. So it is y times p plus q minus 3x, right? Now you could open this bracket and simplify. So we have p plus q as one factor. The other one will be yp plus yq minus 3x. So that is how you could factor the second one, correct? So we have done 2 of these. I'd like you to copy these ones. They're also based on grouping. These are more standard grouping examples. Now in such cases where you have 4 terms, we like to combine 2 and 2, right? So you have to sometimes make a judgment. So here w is common, here z is common. So what we can do is, we can write this w common. So we are left with x plus y here. Here we can take z common, and we are left with x plus y. As you can see, x plus y is a common factor. So we'll write x plus y, w from the first term, and z from the second, and we get our factored form. Let's look into this one, which is 12xy, and then we have 4x plus 3y. Now here, what can we do? 12xy, 12 plus xy, 4x plus 3y. So we may have to rearrange, right? So what we will do here is, we'll combine this term with 3y or 4x. Okay, so we'll kind of take this term with one of these. So let me rearrange this. So let me write this as xy, let's say 4x plus 4x, and let me write this as plus 3y plus 12. Okay, now we can take x common, so we get y plus 4 as a factor, and on this side we can take 3 common, so we get y plus 4 as a factor. Now you can see y plus 4 is a common factor. So it's kind of tricky at times. You may have to rearrange. So we can write y plus 4, and we get x from here and plus 3 from there. So that becomes the factored form for the given expression, correct? Now let's look into the next one. So let me just divide this page. Okay, so here we have x square x, so I can take x common, right? And I get x plus 1. Here I can take y common with a negative sign, negative y common, so we get x plus 1, correct? X plus 1 now is a common factor. and we have x minus y. So you see how we grouped two of them and then factor. So that is why it's called by grouping. The last example here is 3x squared minus x minus 3xy plus y. So the first two factors can be grouped, correct? The next two can also be grouped. And then let's see what do we get. X is common here, so we get 3x minus 1. Here y is common. Let's take negative y outside. So we have 3x minus 1. Since these two are common factors, we can complete factoring. 3x minus 1, and we get x minus y. So that is how we could actually factor these polynomials using the technique of grouping, right? I'm Anil Kumar, and I hope that helps. So there are about 6-7 videos in this list where we'll talk about now trinomials, difference of squares, perfect squares, and other polynomials where factoring could be learned by practice. I hope that really helps. Thank you, and all the best.